may be spent in a paradise you've never heard of. You'll just need a way to get there. Here's the catch. That way has to go underwater. It would become the deepest immersed highway on Earth. Oh, they also have to build a couple of bridges. And did we mention the typhoons? These tugs are towing a contradiction. A tunnel segment that's both colossal and fragile.
Come back, close.
Slow down.
A raft of techno breakthroughs and untested results. Bound for a place few know, to entice the world to visit. And even sway the choice for the Olympic Games. Busan is South Korea's second largest city. 4.2 million people. Bigger than Madrid, closing in on Milan, and as hectic as Manhattan. South Korea is an Asian tiger, and Busan makes it roar. Its skyline will soon include one of the world's tallest buildings. It's the nation's biggest port, and the 5th busiest in the world. Every 3 seconds, they unload a container. It's so busy, they had to build the sprawling Busan New Port. And still, Busan grows. Busan is such a comer, it's bidding for the 2020 Summer Olympics. But Busan has one big problem, and it's on display here at one of Asia's biggest fish markets. Dozens of vendors cram in here, 14 hours a day, every day of the year. And that's the trouble with Busan. It's so crowded, it's running out of room. The solution to Busan's problem lies just across Jinhae Bay. Goje, an island 7 times bigger than Manhattan, but just 1/8 of Manhattan's population. Busan, Goje. Busan, Goje. Goje is a gold mine of development, a potential Korean Riviera, with room for Olympic athletes to hit their stride, and for the Korean tiger to stretch its legs. But Goje has its own big problem: getting there. By sea, Goje lies only 8 kilometers from Busan. But by road, it's 140 kilometers. 3.5 hours, one way. One of the world's worst commutes. Lost time and lost work costs almost $400 million a year. And it could cost Busan the Olympics. The athletes won't come if they can't get around. The solution will slash travel time from nearly half a workday to 40 minutes and revolutionize life on both sides of the bay. the Busan-Goje Fixed Link. A 4-lane highway that runs nearly 50 meters beneath the sea. Then it leaps across 2 colossal cable-stayed bridges. Altogether, longer than 80 football pitches. One of the biggest infrastructure projects in the world. Plunging 48 meters below sea level, the link will boast the deepest immersed roadway in the world. The tunnel will be composed of 18 mammoth segments, each as long as 2 football pitches and as heavy as an aircraft carrier. Wide enough to carry 2 lanes of traffic each way, with an access tunnel between. That's the concrete reality. Now, here's where it gets dicey. Each segment has to be carefully towed into position, then carefully sunk to the seabed. And all the segments have to align within 35 millimeters, less than a thumb's width. Weather adds its own demands.
This site is exposed to the open sea. There are always high waves, and the water is deep as well.
It is wide open to the Northwest Pacific Ocean, so we have extreme exposure conditions for the construction period. So we've got to be ready for whatever that sends us, like big swell waves, strong winds, and even occasional typhoon.
Building a tunnel like none ever seen will take techniques like none ever tried. Yet the Koreans have never built an immersed tunnel. But this country has. The Dutch have 5 centuries of experience at holding back the sea.
De afzinken van tunnels.
Tunnel immersion is actually a Dutch speciality. If you look at the number of immersed tunnels in the world, most of them are in the Netherlands.
Dan zijn verreweg de meeste in Nederland geplaatst.
The Dutch company had a zest for a challenge, and the confidence that they could solve these problems. And so we were able to trust each other. But that's how we ended up working with the Dutch.
This is what confidence looks like.
Moet je even naar Kim hier lopen of die even met jou met dat bootje even?
21 years ago, Peter van Westendorp joined Structon at the bottom and worked his way up. He's worked on 8 underwater tunnels.
Better when it's tight. Yeah.
But none as daunting as the fixed link.
Die sluitboot 101. Er is niks mooier.
There's just nothing better than immersing a tunnel. It's great to work with a relatively small group of people who are so focused on their job
Select the rope, please, Ais.
and put in 200%. That's just amazing.
Construction begins with the tunnel entrances. One on Gaduk Island, the other near an uninhabited island. From here, engineers will dig down to 12 meters below sea level to meet up with the undersea tunnel segments. But they won't tunnel through the seabed itself. If they did, the gradient would be too steep for driving. Instead, Peter's crew will lay prefabricated tunnel segments on the seabed. First, engineers dredge a trench where the tunnel will rest. To buttress the foundation, they bore concrete columns into the seabed, stopping 3 meters shy of bedrock. The reason? Earthquakes. Avoiding bedrock will give the tunnel crucial flexibility. The segments will rest on a bed of gravel to ensure an even surface. Because the bed determines the exact height of each tunnel segment, the gravel must be placed with pinpoint accuracy. Later, the entire tunnel will be covered with thousands of tons of crushed rocks to protect it from collisions with ships or anchors. Because the tunnel segments will be prefabricated, the first challenge is finding land for a construction yard. Not an easy task in Busan.
If you look around, there's not a single metre of flat land anywhere that a contractor can use as a base for the construction period.
From the tunnel site, the closest spot lies 35 kilometres away. It's big enough to build up to 5 tunnel segments at a time. Each segment weighs about 48,000 tonnes and is made of 8 subsections, each twice as long as a London bus. Anyone with a basement knows water can penetrate concrete joints, potentially disastrous in an underwater tunnel. But each giant section is cast without a single joint, thanks to Korean ingenuity.
We continuously poured full sections from the ground up to the top of the walls to eliminate gaps in the walls.
A process lasting 24 hours. After casting, the ends are sealed with steel bulkheads, a Dutch innovation best appreciated later on the bottom of Jinhae Bay. The bulkheads are watertight because these babies are about to take a bath. Flooding the dry dock will allow them to float the segments out to sea.
The inundation of the dock takes approximately 48 hours. During the first phase, we let in water until it reaches the level of the bulkhead door. Then we'll check to see if the bulkheads are leaking. Once all the leaks are repaired, or if there are no leaks, we'll fill up the dock completely.
It's enough water to fill 230 Olympic pools. So how do you prep 48,000 tons of dead weight to float?
Inside every tunnel segment, there are 6 ballast tanks, and they're filled with water.
Ben, alle kleppen staan open, dus voor mij mag de pomp aan.
To start the flotation process, we begin pumping out the water. We continue until the tunnel segment starts floating.
So what the tugboat has to do is to tow that slow. Then with the other winches at the backside, we control the tunnel element sideways direction.
Now they can begin to warp out the segment. Removing the first segment takes brawn and finesse to avoid colliding with the dry dock.
Pas erop dat hij niet van het dek afrijdt, hè?
With barely 2 meters on each side, there's no room for error.
Oké, Maurice, we zijn er doorheen, we zijn gekruist, dus we kunnen zo gaan remmen.
Al bij de boten zijn bezig.
Ja, goed jongen. Ja.
Believe it or not, clearing the dry dock was the easy part. While work continues on the undersea tunnel, the rest of the Busan-Goje fixed link starts to rise. 2 giant bridges. One with 3 pylons, the other with 2. At its topmost, the 2-pylon bridge will soar 156 meters above sea level, the height of a 50-story building. The span between the pylons will stretch the length of 5 football pitches, with enough room for the tallest freighters to pass under. Crucial for a city that thrives on shipping for its livelihood. The most pleasing aspect of the bridge is also the most daunting. its curved diamond shape.
Of course, curved pylons are very difficult to construct, but they're very much in harmony with the surrounding scenery in many ways, in that they bear resemblance to a mother's praying hands and to the wings of seagulls.
35 kilometers away, the first 5 tunnel segments arrive at a temporary mooring site. From here, they'll travel across Jinhae Bay to their resting place on the sea floor, already leveled and lined with gravel. And here's how they'll get there. Pontoons the size of a mansion. Dutch designed, Korean made. One pontoon is positioned near each end of the tunnel segment. After arrival at the tunnel site, mammoth winches on pontoons will lower the segment to the seabed. At least, that's the theory, because it's never been done in the open sea. A specialist diving team prepares the first tunnel segment for the immersion operation. Divers test connections for data systems and power supplies.
Standing by.
And remove marine growth from the bulkhead.
Down on the wire, please, Steve. Down on the wire.
Finally, they install steel wires underneath the tunnel segment, crucial for positioning during immersion.
In a good position now, we can come up on the wire. Coming up on the wire.
Above water, the crew are also adding a temporary access tower, so workers can enter the segment in case of trouble with the ballast tanks.
Over, the tunnel is clear.
Every problem has to be anticipated, because if things go south, they won't get a second chance.
What we do doesn't have anything to do with luck. We know what's involved, we know how the process works, and we have the feeling we control the whole process.
Not quite. Back in Holland, the rest of the immersion team stands by to fly out. In all, 56 men wait for Peter to say go, and he's waiting for a forecast. When the wind blows from the south, swells roll in from the Pacific.
Because we're situated offshore, we have to deal with waves. And these waves can be pretty fierce.
Even swells barely 30 centimeters high pack so much force they could fracture the subsections that form the tunnel segment. Throughout its journey, the segment will be at the mercy of the waves, so the team needs 3 days of calm seas. Structon looked around for a forecaster, but few dared to stick out their neck for such a costly guess. Then, a Danish company seized the challenge. They came up with a model to predict waves as small as 10 centimeters, up to 5 days out. A stunning breakthrough in forecasting.
That means we're able to say, tomorrow we can do an immersion. And that means we're able to put people on the plane yesterday, really on a last-minute basis. It takes away a big risk for us and for our client.
We've got the weather. They're all showing the same prediction. The swell still not as bad. I would say we have a go.
Green light.
We'll try.
Then we'll try, right?
Okay, thank you. Yes, bye-bye.
Ahead lie 48 hours of tension for the boss. Six months of work, rides on steel threads, and a forecaster's guess. Tonight, no one will sleep soundly. After a cautious voyage at 3 kilometers an hour, the first tunnel segment arrives at Garduk Island, the starting point of the tunnel. Joining Peter is the elite team fresh from Holland, among the few men on the planet who can do this job.
Gooi je anker 6 maar weer overboord. We gaan eerst de longtunnel secundair pakken.
But working along shore poses a huge challenge. 48,000 tons have to be maneuvered into a slot with just 1 meter of clearance underwater on each side. One false move and the segment could get jammed in the rocks. Controlling the segment are 14 steel cables, anchored in the rocks and on the seabed. Aligning the segment takes painstaking accuracy. Surveyors take readings using a system of prisms and mirrors mounted on the access shaft and the survey tower. It's all new to the Koreans, so it takes time getting used to the technology. The ordeal will take all day and end either with an engineering triumph or a 48,000-ton disaster. With so little clearance and so much at stake, the segment moves at a snail's pace. After a journey of 35 kilometers, it's now just 4 meters from the abutment.
We've worked really hard for a half a year to prepare for this moment. 56 of our people are here to execute this operation. The Koreans are excited and tense because they've never witnessed this. We've done it more often, but still, a very special moment.
Till now, steel plates have protected the leading edge of the segment.
Easy down.
Behind them is a component as crucial as it is fragile. A rubber gasket to ensure a watertight connection with the abutment. Now they're ready to begin the descent. Operated by remote control, the ballast tanks slowly fill. The command post monitors everything via remote control cameras, on the pontoons and inside the tunnel segment.
Oké, heren, jullie mogen wat mij betreft alle 4 tegelijk laten zakken.
The segment must align with the mouth of the tunnel to within 3.5 centimeters.
You can imagine that if this segment were placed 10 centimeters off and you did that 18 times, you'd end up 2 meters off on the other side. Well, that wouldn't be very good.
7 hours later, touchdown. The segment now rests just 50 centimeters from the abutment, the mouth of the landward tunnel. To close the gap, engineers have installed a pair of powerful hydraulic jacks. Linking the jacks and applying tension closes the gap. The final stage begins from the landward side. A wall of water nearly 3 meters wide separates the segment from the abutment, what they call the immersion joint. Opening this valve will force the water out. As the immersion joint empties, external pressure will further compress the gasket for a watertight seal. The echo from the bulkhead reveals the water level in the joint. With the water drained, they can open the bulkhead door. But the lock's jammed.
You know that he was going to break.
Huh? Did you know that? Because you took the toolbox with you.
This calls for cruder technology. All that stands between the crew and the first immersed segment is the steel wall installed back at the dock. And here is why it's so brilliantly simple. On other tunnels, engineers seal the ends of segments with concrete, then knock it out after immersion. But that takes time and creates debris. The modular steel bulkheads are easy to install, easy to remove, and they'll be reused on every segment and eventually recycled. Faster, cheaper and safer. An engineering trifecta. Finally, open sesame.
Although we experienced some unexpected things, we were very happy that it was completed successfully in the end. And the feeling of accomplishment was indescribable.
Their marathon operation lasted almost 78 hours. Some have gone 2 days without sleep. One down, 17 to go. And they won't all go smoothly. Like the Busan tunnel, the bridges advance in segments, but 2 at a time, not 1. It's called balanced cantilever construction. Working outward, steel segments are laid on each side of the pylon to keep the bridge in balance. Then 2 cables are attached to brace the segments.
Once they've done that, the derrick crane then lifts up 6 precast concrete panels and places them onto the steel frame. Then put a final post-tensioning into the cables. And we're ready then to start the whole thing over again.
Back at the tunnel, the team have installed 12 concrete segments. But now they're heading for 48 meters, the deepest water and the hardest challenge.
Martin, 202 zit ook vast.
202 vast,
oké. Die schop even achteruit lopen. Daar naar achter. Kom maar.
New hurdles demand new techniques.
Dan gaan we die 505 weer vastmaken.
Ja.
The sea floor out here is soft clay, so they need to set anchors that can hold the segment and pontoons fast. Stev mantas, named for their fish-like shape. They're designed to dig in where other anchors lose their grip. Once segment 13 arrives here, 14 steel cables connected to the anchors will hold it in position. But once again, deep water raises the stakes. Once the segment hits the bottom, suppose a problem arises with the ballast tanks. Somehow, Peter would need to get the engineers inside. On segment 1, they could use an access tower, but not in deep water. The solution is a first in tunnel immersion, a self-propelled diving bell. Purchased in America, the sub was refitted just for this project.
I'm coming down to 15 meters, see if we can get the tunnel on sonar. This is the tunnel element here. That's something probably bollard on the corner.
With a little boat like this that can go to 300 meters, you've got the concept of a ferry transferring people to the tunnel segment.
It's 9 meters long, with room for a pilot, co-pilot, and 5 engineers. It can dock on a landing tower on the segment for watertight access to the tunnel. Deep water poses another problem: monitoring the position of the segment as it's lowered, because one misalignment would be disastrous. To calibrate the position of the first segment, surveyors took readings from prisms mounted on the access tower. But remember, there's no access tower here. So once more, the Dutch devise a smart, simple solution. It's named for what it is: a taut wire. One end attaches to the leading edge of the segment to be immersed. The other end attaches to the previous segment. The taut wire ensures the connection stays under high tension. Positioning the device is a delicate operation. This custom-made model is the only one in existence. Breaking it is not an option. When this segment descends, a computer will record the length and angle of the wire, allowing the team to monitor the segment's position.
The taut wire is nu op high tension.
The taut wire is now under high tension between this segment and the previous one. And as the segment descends, the wire automatically retracts and becomes shorter. So that provides us with exact positioning data.
To fine-tune the position of the segment on the seabed, 4 of these sensors are attached, one on each corner of the bulkhead. Another custom innovation for this project. And wait till you see how accurate they are. The whole operation is remote controlled from the command unit on the pontoon. With one click, they start filling the ballast tanks.
You can feel the tension building up now. And then we all have one question: can we do it again? Can we get it in position? It's the same tunnel, but it's farther away from the coast. It's deeper, the weather, everything. So many aspects make it different every time, so you have to stay alert.
All the data feeds into Peter's computer and refreshes the position of the segment every second.
This is the tunnel where we have to go to. The green one is the final position, and this is where it is now. So you can see it's just below sea level.
Die contractie is zeker 2, even terug naar rond de 10 ton houden en die CSN even wat zwaarder laten belasten, Anne.
Data from the winches allows him to adjust the segment during descent. It all happens like walking downstairs. One step forward, one step down. And the deeper it goes, the more careful the steps.
At this stage, where the tunnel is just a few meters underwater, there's no problem. We can still move in any direction. Nothing can hit it. But when we're approaching the segment that's already on the bottom, then I have very little clearance, so the steps I make will be a lot smaller.
It takes 7 hours to descend 48 meters, just 9 centimeters a minute. The first step in joining the segments poses another challenge and another solution.
Op het moment dat de
The moment a tunnel segment approaches the one ahead of it, it's moving because of the swell. So we install 2 guide beams on the top end of the segment.
Another simple but elegant solution.
The moment we pull them closer together, the guide beams become less flexible. The movement diminishes until the segment is motionless.
With only 50 centimeters separating the segments, and in near zero visibility, a diver connects the hydraulic jacks. The segments seem aligned, yet the slightest error on this end will translate into a big mistake at the other. But the Dutch don't miss a trick.
Kan ik er nu al gaan uitschuiven? Ik zit erbij.
The 4 remote-controlled sensors on the bulkhead now deploy. They measure the position of the segment within 1 millimeter, the width of a guitar string, and relay the data back to the command center. Peter needs to shift 48,000 tons of concrete, 20 centimeters to the right. Even on calm days, the swell is so heavy and the segment is so long, stability is a problem. The solution? The External Positioning System, or EPS. Yet another Dutch invention based on a simple idea. A pair of hydraulic legs and extendable feet to hold, lift and move the segment. Connecting each pair of legs are 4 steel cables, already installed back at the mooring site. Braced on its robot legs, the EPS laterally aligns the segment into its correct position. Now, the jacks are tightened by remote control, compressing the rubber gasket. Done. One more segment, complete. Like the tunnel, the bridges approach the final stages. Before the 2-pylon bridge can accept its last section, engineers have to perform a stretching exercise, as tiny as it is powerful. Both pylons have to be pulled back about 7 centimeters to create enough space for the key section to be placed. Once the tension is released, the final section will have a tight fit. After 6 years, they must be eager to finish. But just like the tunnel crew, they have to move in baby steps. Because this baby is a giant. A few kilometers away, Peter's crew prepares to install their last segment. Just like the first segment, number 18 has to be maneuvered between rocks. As before, they run some of the anchor lines from the pontoons to the rocks.
Because it's so close to the island, it's very difficult to install the immersion wires. Connecting them isn't easy by any means. It's not just a matter of simply pulling them in place.
With all cables attached, they can start maneuvering the segment into place.
Because this segment is extremely heavy, we can't afford even a small mistake. Light contact can cause huge damage to the segment, and that kind of damage can set back the entire project.
After 3 years, they'll open the last tunnel segment tonight, if all goes well. The segment hits the bottom, but there's trouble. One end is sitting 28 centimeters too high.
We're now trying to figure out what the cause is. We don't know yet. It's a major problem at the moment. We're taking about half an hour to go through all the steps so that we don't miss anything, and then I'll inform you about the situation.
The gravel foundation under one of the EPS feet is overbuilt, so they'll have to remove the foot. And the grand opening will have to wait one more day. After final adjustments, the last tunnel segment now sits squarely on the sea floor. All that's left is entering the tunnel to seal the joint with the final segment. They'll enter via the tunnel entrance on Garduk Island. It's the last time Peter will make this trip.
Je begint ergens aan 3 jaar geleden.
You start something 3 years ago, and the first time you think, gee, still so many to go. But time flies. Now it's the last one. That feels kind of strange. Mixed feelings. Glad it's almost finished, but it's a pity we can't do one more. We're approaching that moment again. It's at the bottom, opening the door, hoping it'll all be okay.
After 3 years, light at the end of the tunnel.
De klep gaat nu open op standje 1.
The last step is pumping water out of the immersion joint, so the segment can close up for a tight seal.
Maurice, Peter, we hebben water in de ballasttank. Zie jij al de tunnel bewegen?
Ja, we zijn al iets beter ervoor.
Oké, prima. Ja, 3 mm.
They always celebrate this step, but today is the grand finale. Once complete strangers, now firm friends, and soon to go their own way. The end of their long journey lies behind this bulkhead door, and the honor of opening it falls to Peter. Back at the bridge, the final section is lifted into place. Once the tension on the towers is released, the whole structure will be locked in place. With the bridge complete, all that remains is opening the final segment of the tunnel. Last inspection.
Really extremely proud that we did it, and happy, of course. Happy for the whole team. It's just great. After all this time and after a difficult operation, we did it. Very emotional, yes. Fits the moment. And proud. So proud. Yeah.
Come back.
For Peter's team, the tunnel marks another success on a stellar resume. For the Koreans, it's a chance to join the Dutch on the world stage.
Actually, this was the first immersive tunnel project in Korea. And we developed lots of new equipment, and we trained lots of engineers, and eventually we could finish in time, and everything is happy.
This isn't just a shortcut to an island. It's a path